Good afternoon friends, I welcome you all in this session. As you are aware, in previous session we were looking at different types of scales of measurement, and we have seen that basically there are two types of scales, numeric and non-numeric. So, you can say that non-numeric scales are nominal and ordinal, and numeric scales are interval ratio. We have seen in detail in previous class about nominal scale, and the purpose of nominal scale is to identify a person, a product or a group or any other thing, just for identification purpose. For example, roll number of a student, it is just for the identification of a particular student. It does not mean that roll number 1 and roll number 30 students, then roll number then the student who has got roll number 30 is 30 times intelligent, right. So, they are just for identification purposes. So, we have seen an example as well in previous class. So, let us say you can have a nominal scale like you can have a different departments in a university, business school, humanities department, education department, civil, electrical, mechanical. So, these are nothing but nominal scales. For example, gender is also a kind of nominal scale. So, you can say male, female, group 1, group 2, yes, no, right, all these are nominal scales, and of course, you can convert nominal scale into a metric scale by assigning some numbers to them, right. For example, 1 to business school, 2 to humanities and so on, right. Let us look at ordinal scale. As I said, nominal scale is just for identification. Ordinal scale is basically a scale which tells you that this particular person has got more characteristics than some other person or some other persons, or a product A has got more characteristics than product B. So, this order can be measured through ordinal scale. I will tell you a very good example. Let us say in an examination 100 students have appeared, right, 100 students have appeared, and all of them wrote 5 papers, right, and each paper is of 100 marks. So, total marks are 500, is not it, total marks are 500. Let us say the topper of the examination is, let us say, scored 495 marks. So, we will say that this fellow has got rank 1. So, this is nothing but rank order scale 1. Then you will have some more students. So, similarly, let us say this is serial number 1, right. So, you will have total 100 students, is not it. So, the last student will have rank 100. So, let us say the last fellow got just 300 out of 500. Now, the fellow who is at second rank, it means this fellow has got more features or more characteristics than this fellow, but rank order does not tell you how much is the difference between rank 1 and rank 2 students as far as marks are concerned. So, that is the major drawback of ordinal scale. It will tell you that this fellow has got more marks, he is better student, but how much better, is not it. So, that is the drawback of ordinal scale, and this drawback is or it can be removed if we move on to the next level of scale or the next type of scale, which is interval scale, and interval scale is a metric scale. Let us look at example of ordinal scale. So, students of a university are classified their class standing using non-metric label, so such as freshman, junior, senior and so on. So, you can just give them numeric code. 1 denotes freshman, 2 denotes this, 3 denotes junior, and 4 is senior student. So, this rank 1, 2, 3, 4, right. So, this is rank order scales example. Let us look at interval scale. So, interval scale will tell you how much more characteristics a student has got compared to other students, which was not possible in case of rank order scale. So, in case of interval scale, the data have the properties of ordinal data, of course, and interval between observation is expressed in terms of fixed unit of measures. So, let us take an example of interval scale. So, let us say you are measuring attitude of a person towards a new brand of car. So, you can have a scale like this 1, 2, 3, 4, 5, a Likert scale having 5 categories. So, if the respondent is strongly liking that particular brand of car, so he will tick over here. So, strong liking and very less liking, right, or you can put it in terms of whether the fellow is strongly agree or not, or strongly disagree, right. So, you can have a scale like this. So, strongly agree, this is neutral, right, this is strongly disagree. So, this is somewhat, or let us say disagree, isn't it. So, these are 5 categories of this scale. So, we know that the distance between these two is 1, and we know that distance between these two is 3. So, this is we can have fixed unit of measure, right, because there is something fixed over here, right. So, if you take this as the starting point, then this is the last point. You can take the vice versa also. You can have this strongly agree as 1 and strongly disagree as 5. You can have a scale like this as well. So, that is interval scale. It tells you how much characteristics a product or a person has got more or less compared to others. So, they are always numeric. Let us look at an example. Melissa has a set score of 1205, while Kevin has score of 1090. So, Melissa has got these many more marks, or Melissa's score is 115 points more than Kelvin's. So, this is, so you can know how much is the difference, right. So, here difference is 115. This is interval scale, and finally, the ratio scale, which is again a metric type of scale. The data have all the properties of interval scale, and the ratio of two values is meaningful in case of ratio scale. So, we measure variables like distance. So, distance, height, weight, income, number of houses, let us say number of family members. So, all these are nothing but ratio scales, because in ratio scale your 0 point is fixed. So, when we say 0 while using a ratio scale, it means nothing exists as far as that particular variable is concerned. When say height of a person is 0, it means of course, you can't have a situation like this, right. So, if this scale contains a 0 value, it means nothing exists in that particular product, right. So, Melissa's college record shows 30 credit hours earned, while Kelvin's record shows 72 credit hours earned, right. So, we can clearly say that this fellow's credits are more than, or exactly double than this fellow's credit hours, right. So, this ratio is important in this case. So, you can have data again in terms of qualitative data and quantitative data. Earlier sessions we have said that you can have primary source of data, secondary source of data. So, you can have another classification of data, qualitative and quantitative. Now, what kind of analysis you are going to do on data? It is very important to use a particular type of scale. So, let us say if you have got qualitative scale, for example, a nominal and ordinal scale, then you are doing some sort of statistical analysis. You can't do some other statistical analysis on qualitative data. Similarly, if you have got quantitative data, then also you have got some statistical analysis. So, if you have got let us say quantitative data, then you can have more options as far as statistical analysis are concerned, and these options get restricted when the data are qualitative in nature. So, qualitative data are obtained from which two scales? Nominal and ordinal, right. So, this is also referred as categorical scale or non-metric scale. So, use either nominal or ordinal scale, as I have already said. So, of course, you can convert nominal and ordinal scale into some numeric numbers, right. Some numbers can be given to these two scales. As I said, the statistical analysis are limited in case of qualitative data. Okay. If you look at quantitative data, of course, they always have to be numeric, isn't it? Data again quantitative can be discrete or continuous. We have already seen discrete data and continuous data. Ordinary arithmetic operations are meaningful for quantitative data. You can't find out, let us say, mean of qualitative data, right, isn't it? For example, red and blue, what is the mean? You can't have mean, isn't it? So, in case of quantitative data, you will have some meaningful arithmetic or statistical operations, right. So, broadly what we have said, you have got qualitative data and quantitative data. So, quantitative scales, interval and ratio scales. If you have got qualitative data, you have only just two, right, nominal and ordinal. Now, this can be again numeral and non-numeral, right. This is what we have already seen. Let us look at what is cross sectional data. Cross sectional data means data collected over a period of time, just one time you have collected data. For example, the census data Government of India collects after every 10 years, right. So, let us say last time the data were collected in 2011. Okay. So, we will say that is just a cross sectional data. It is just like a picture of a situation, right. So, example can be the number of building permits issued in June 2017 in each district of India, right, and we will have a cross sectional data, right. But if you collect these data after let us say every 10 years, if you have got data from all districts after every 10 years, then it becomes a time series data, right. So, data collected over a period of time are series data, right, or time series data rather than cross sectional data. So, let us say data detailing the number of building permits issued in city in last 36 months. So, you will have 36 data points, right, isn't it, 36 data points. So, this is time series data. So, we can say that time series data are like video, right, or film of some situation, right, while cross sectional data is just a picture, right. There are different sources. There are several sources within a firm. In a firm you will always have data in different departments or different verticals of the firm, be it related to let us say marketing or sales data, or let us say number of new products you have rolled out. In HR department, the number of people working in the organization, how many people are going on leave, what is the turnover rate of the employees. In finance data, in finance department you can have data related to what are the sources of funds, what is the return on investment, what is return on asset, and so on, right. So, within a firm you can have data, right. And apart from within firms you can have other sources like business database services. So, you got let us say in India you have got National Stock Exchange, right, or Bombay Stock Exchange, let us say New York Stock Exchange, right. If you talk about business database services, so you have got let us say some other stock exchange of some other country, right. You can have government sources, of course government departments. In India you can have data from different ministries, right, finance ministry, HRD ministry, Ministry of Statistics and Planning Implementation, Ministry of Water Resources, and so on. So, there are several ministries. So, you can get data from government agencies as well. There are several industry associations. For example, in India we have got FICCI, it is Federation of Indian Chambers of Commerce. You have got Confederation of Indian Industry, CII. You can have let us say SIAMS, right, Society of Indian Automobile Manufacturers. You can have data from NESCOM, right. So, SIAM is there, FICCI, CII, all these are industry associations. National Association of Software Companies, right, NESCOM. So, special interest organization. So, there are several other sources apart from these sources, So, you have got let us say how many institutions are working in India as far as technical institutions are concerned: AICTE, All India Council for Technical Education, Medical Council of India, Pharmacy Council of India, and so on, right, UGC and so on. So, these are special interest organizations from where you can get data, and of course, internet is one of the sources of data. You can also have data from experimental studies. So, let us say you are doing some experiment in laboratory. So, you want to measure some output with some given inputs. So, this is your output and these are different inputs in an experiment. So, you can measure output, right. So, what are different inputs, how those inputs are affecting output, right. So, these are experimental data. So, you can control some of these inputs, right, and you can see how this output is getting affected when you control or when you change one of the inputs or all of the inputs, right. So, this is known as experimental studies. You can have observational studies. So, here you are just observing some situation and collecting data. For example, as a survey through let us say survey can be put under this category. Okay. So, this is you can these two can be termed as statistical studies, right. Data acquisition considerations, you need to consider so many things because you need to spend time, you need to spend lots of money, you would be taking time of respondents whenever you are doing any survey. So, there are different costs involved in it. So, as I said, it is consuming process, time consuming, and many times sometimes what happens when you need some data and if data is not available. then you will not be able to complete your studies. But sometimes what happens, by the time you get data, the data may no longer be of useful for your study, right. So, time is important factor. Cost of acquisition, of course, there are lots of costs involved in data collection. So, you have got, let us say, field workers, your supervisors and so on, to whom you are paying their salaries and wages. So, cost of acquisition, sometimes you acquire data from some other companies. So, there are some syndicate services. So, these are the companies which collect data and create pool of data. So, if you want data from that company, you can get data by paying some charges, right. So, cost of acquisition is there, and of course, data errors, try to minimize data errors. Okay. Let us look at data representation tools. First, we will look at some tools, tables, graphs for descriptive statistics. So, let us look at this example. So, there is a manager of Hudson Auto and would like to have better understanding of the cost of parts used in the engine tune-ups performed in the shop. He examines customers invoices of 50 customers invoices for tune-ups, and he wants to know what is the average cost of tune-ups. So, these are different costs. So, for let us say for one automobile, this was the total cost. For 50th, this was the cost. So, he had lots of invoices and he chose only 50 out of those lots of invoices. So, let us look at tabular summary, frequency and percentage frequency. So, this is how you can prepare frequency and percentage frequency. So, first of all what you need to do, you need to prepare different classes. How many parts have occurred, this much cost. So, we will say that there were only 2 values in this range 50 to 59. Can we let us check whether there were 2 or not, 50 and 59, right. So, 50 and 59. So, this is the one, and 50 and 59, yeah, this was the second one, right. So, frequency between 50 and 59 is 2, right. Similarly, you can write down frequencies over here in these classes, right. So, this total frequency should be 50 because you have taken sample of 50 units. Calculate percentage frequency, just divide 2 by 50, is not it, multiply it by 2, right. So, this how you will get percentage frequency, and this total should be 100, right. Now, you can have a histogram of the same example. So, this is your histogram, these are your classes and these are frequencies, right. So, just by looking at this particular histogram, one can get idea what would be the tune-up cost. So, what do you think, in which range this cost varies, is not it here, right, maximum is 16, right. So, this is, so the cost should be somewhere between 70 to 79. So, what would be the exact average cost? Of course, you can just take the mean of all those 50 points. So, you just take summation of all these 15 costs and divide them by 50, right. So, it is 79 rupees. right. So, this is how you can prepare table frequency and frequency percentage. So, in this case what we did in previous example, we did infer something from statistical analysis. So, we will call it a statistical inference. So, there was a population, right, all the cars which came to that particular auto garage, auto shop, we took a sample of 50 cars, and on the basis of those 50 cars we estimated and we concluded that the average cost was 59. Process of statistical inference, what we did. So, there were several units in the population, we took 50, we just took the average of all those 50, and on the basis of that average of the sample, we have said that the cost of repairing each automobile was 50 rupees for all the automobiles which were there in population, right. So, what we have done, we have infer something about population from sample, is not it. So, this is the process of statistical inference. So, there are different packages and tools available for preparing these charts, tables, pie charts and so on, and there are some other statistical packages available. So, Minitab is one of them. So, you have got SPSS, you have got SAS, you have got R and so on, right. Of course, Microsoft Excel is an excellent tool which can be used for data analysis. Both these use worksheet to store data. Of course, many of you would have worked on these two. So, if you are using these programs properly, then you need to understand how to operate the program, understand underlying statistical concept. This is very important. You know how to operate a software, but if you do not know what is the statistical meaning of the output, then it has no meaning. So, you should be able to understand how to organize and present information, the output which you are getting, know how to review result for errors, because there is possibility of having error in your results, and you should report the possibility of error or the probability of errors. For example, if you say that tomorrow it will rain in a city, then you should say that there is a probability of rain 90%, right. So, there is 10% chance that it may not rain, right. So, let me summarize what we did in last 3 sessions. We looked at population, sample, primary and secondary data, categorical versus non-categorical data. We have seen 4 types of scales. We have examined descriptive and inferential statistics. We have reviewed data types, whether it is a quantitative data or qualitative data, and we have also seen different types of softwares which are available, maybe as I said R or SAS or SPSS, Minitab, Excel and so on. So, as far as this particular topic is concerned, we will have it in next session. So, with this let me complete today's session. Thank you very much.